Okay, so we know by now that work done by a given force is equal to the magnitude of the force times the magnitude of the displacement times the cosine of the angle in between the force vector and the displacement vector. Or in other words, the parallel projection of the force in the direction of the displacement. Now, if we have a bunch of forces acting on an object or a system doing work, and those forces are constant, we can find the work done by every individual force by simply finding the magnitude of the force, the magnitude of the displacement, and multiplying it by the cosine of the angle between the displacement and the force. And that goes for any force, so for applied force or for tension. Now the thetas might change because the angle between the displacement and each given force isn't necessarily the same. So let's call this theta A, theta T, theta G, just so we recognize that these are potentially different. And so one approach to finding the total work is find the individual work done by all the forces acting on the object and then add them together. So the net work, the sum of all the work done by all external forces acting on an object or system, is simply taking those works and summing them up. Now, some of these will be negative, so we're going to be adding the negative work, but I'm writing them all as positive as the sum of. Or we can look at net work as the overall net force, magnitude, times the displacement. And again, I'm not being consistent with putting the absolute value in the vector symbol every time. This is just magnitudes, but I will to remind you that this is magnitude of the force, magnitude of the displacement, times the cosine of the angle between the displacement and the net force. So two different approaches to net work, summing the individual works done by the forces, or by finding the net force first and taking the cosine of the angle in between it.